Hi, I'm Elisa, and we are learning about the nervous system. So now I wanted to take you on a multi-part. So this is going to be part one of membrane potential and the action potential. So action potentials are electrical signals, right? So these are produced by the opening and closing of specific voltage gated channels in the membrane. Okay, only where we have enough of these voltage gated channels, right, are we going to actually see this signal occur due to the change in the electric and due to the change of the ion density around it. So we call these areas where we're going to see these high concentrations and the start of a propagation with the trigger zone along the axon, right? And so we'll look at where that is. So if excitatory local potential reaches the trigger zone and they're still strong enough, what's going to happen is it's going to pop open those channels, right? And they are going to allow charges to move through with different types of ions. And that's going to send us into action potential, right? Right, into an action potential. So it's important to remember we looked at excitatory postsynaptic potential and inhibitory postsynaptic potential, or depending on how you're viewing things, you will soon. But they are only going to be triggered by excitatory, right? Inhibitory is going to turn it down. So local depolarization is going to spread to the axon hillock, if you remember. So if there's a neuron and there's the axon hillock is that large area right before we go into the long spread of the axon arm proper. So what has to happen is we do have to reach threshold. And if you remember threshold, that's our negative 55 millivolts, right, in that area. So what happens is as soon as we've pulled ourselves out of that, negative 70 millivolts, and we've reached that threshold, we will be able to move into an action potential. Okay, so our voltage gated channels will open up and amplify this from threshold through this like large incline all the way up to 30 millivolts. Okay, so that's what those voltage gated channels are actually working towards doing. So as sodium enters and depolarizes that membrane further during this part right here, it actually opens up more and more channels in the area and kind of sends off this local depolarization event. And that's all that's required in order for us to actually send or fire off a signal by using the action potential. So it's very quick, and we actually call it a spike, which is what kind of like makes go, right? So this is that spiking occur right there. Depolarization, it means that we are moving our membrane from being, normally it's pretty negative on the inside and pretty positive on the outside. So that is polarized, right? So we have charges distributed on either pole, right? So like if you have a planet and this is the North Pole, that's not west. I'm sorry. I made strange N. There we go. The North Pole, there it is, and the South Pole might be negative, the North Pole may be positive. And since all the charges are collected either on one side or the other, that's why we refer to it as polarized, right? Just like we see here in this example axon that I drew. So the charges will flip and positives will go in, negatives may come out, primarily positives move around. And when we are trying to fix this back up to where we can fire again, right, after we've spiked, now we go through this period here on this downswing of the slope called repolarization. And we actually go so far down that we hyperpolarize it, right? And that prevents things like a return of a signal in the opposite direction because of all these stimulated and now open voltage gated channels. Okay, so membrane potential is the most negative for a brief time just because the membrane permeability to potassium is actually really high, is more so than at rest, right? And so these voltage gated or the leaky, you remember the cat door because potassiums are so teeny tiny, right? Channels, here's a potassium, right? Those are always open. So they're able to kind of slip back through, and they're the ones that are going to go back and forth until we reach equilibrium. Okay, so here we have our action potential. So here's our resting membrane potential. Excitatory potential is achieved here. Excitatory postsynaptic potential. Sometimes we need to summate it, right? So that's those graded potentials are discussed in some other videos, but there it is now. All we need to do is achieve threshold, so that just means we need to make the inside just a little bit more positive. And once we do that, those voltage gated channels open up nice and wide, allowing for that immediate and rapid spike up to about 30 millivolts. On this chart, they have 35. Times change, I guess. And then we have that repolarization event as we re-establish the membrane, getting it ready for the next time we fire. And we actually hyperpolarize just a smidge, as you can see down here, until we are restabilized right back at that negative 70 millivolts resting place. Okay, so I'll go over the action potential a little bit further. I want to talk some more about those gated channels, but for now I just kind of wanted to leave you there and make sure you've gone through the different components of the action potential, and then of course our return back to resting membrane potential, or RMP. If you have any questions, feel free to come by my office during office hours. I love to talk and I'm always here. All right, have a wonderful day.